Hello friends, this video on chemical bonding part 34 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 33. So yes, the question says you need to take the skeletal structure of this, but some of the bonds are not correct. We have to write the correct structure. If you see this hydrogen has 4 valence electrons, it's not correct. The correct structure we know is H. This is the correct structure. So now let's see, this guy should have 8 electrons. So we have 4, give it 8. So this guy should have 8 oxygen. This has already 4, 8. Carbon should have 4, carbon already has 4. This is the structure of my acetic acid. Apart from tetrahedral geometry, another possible geometry for CH4 is square planar with 4 atoms at the corner of the square and C at the center. The question is why CH4 is not square planar. See, let's prove by the valence bond theory. So for a molecule to have square planar, the hybridization required is dsp2, right? Carbon is the second period element. Carbon, it is not having doesn't have d orbital, correct? Since d orbital is not there, dsp2 hybridization is not there. If dsp2 hybridization is not possible, square planar is not possible, right? Because for it to be square planar, hybridization has to be dsp2. Also, my VSEPR theory also supports the structure of my CH4 to be tetrahedral, right? And with valence bond also, we see that in CH4 carbon goes for sp3 hybridization and it has tetrahedral shape. Explain why BeH2 molecules has zero dipole moment, though BeH molecules bond are polar. So if you see this shape BeH, it is something like this, right? And this is more electronegativity, so it will pull toward itself. The net dipole is 0. But if you see BeH has a dipole, BeH also has a dipole, but the net dipole is 0. They both cancel each other. Which of NH3 and NF3 has hybrid dipole moment and why? So it is seen here that NH3 has higher dipole moment than NF3. Why? See, NF3 has NF dipole is stronger because fluorine is more electronegative. But these dipole, if you see, is in this direction, and there is a dipole for the lone pair in this direction, and they cancel each other, right? This dipole cancel with each other, so the net dipole is less. But case of NH3, all these dipoles are in this direction, and the dipole for this lone pair is also in this direction, so it adds up. So the dipole is more, right? The net dipole of the molecule is more. What does mean by hybridization? Describe the shapes of sp, sp2 and sp3 hybrid orbitals. Hybridization is nothing but intermixing of atomic orbitals of slightly different energies, forming new set of orbitals of same energy and shape, right? And the hybrid orbitals have minimum repulsion between the electron pairs and these are more stable. Also, this hybridization indicates the geometry of the molecule. So we have different hybridization. sp will give a linear shape, sp2 will give you a trigonal planar, and sp3 gives tetrahedral. Describe the change in hybridization, if any, for this reaction. AlCl3 plus Cl minus gives AlCl minus 4. See, if you talk about AlCl3, my aluminium is configuration is 3s1 3p2, right? So it goes for sp2 hybridization for AlCl3. Thus, since it is sp2, my shape is trigonal planar, right, for AlCl3. But when I talk about AlCl4 minus, it has to be 4 orbitals, right? So the empty 3p orbitals which it has, example, if you see, this is S and 3p, this is the shape, right? The empty 3p orbitals which it has, that also is involved in the hybridization, and sp3 hybridization takes place here. And it gets tetrahedral shape. Why? Because if you see AlCl4, it needs 4 bonds, right? So it has to be sp3 hybridization. Correct? Similar question here. So my Bf3 plus NS3 becomes this. It's asking that if there is change in hybridization for B and N. So if you see my B, boron, so it is in this shape. Next cycle state, right? And it goes for sp2 hybridization. We talk about nitrogen, it is in this shape, right? All these 3 are filled, so it goes for sp3 hybridization, nitrogen generally in NH3, and BF3 it goes for sp2 hybridization. But when you talk about this compound, we have B in center, you have 3F, we have NH3, you need 4 bonds, right? So minimum sp3 hybridization is required for boron. So here it was sp2, now it is sp3. So boron moved from sp2 to sp3 in this case, correct? Earlier it was sp2, because atomic number is 5, if you see, 1s2, 2s2, 2p1, but in the excited state it becomes 2s1, 2p2, right? It is sp2, but for this particular compound it has to have 4 bonds, so it will be sp3 hybridization. So you have to explain the formation of double and triple bond in C2H4 and C2H2, C2H4 and C2H2. So in C2H4 we have sp2 hybridization, and C2H2 we have sp hybridization of carbon. So let's see this with this diagram. So I have the C2H2, I have this carbon. So in carbon I have this 1s2, 2s2, 2p2, right? Carbon atomic number is 6. So this 2s, see, this is the carbon. I'm talking about C2H4. So I have 2 carbon molecules here. So I'm talking about this outer valence electrons. So I have 2s2 and 2p2, 2s2 and 2p2. Now it goes to the sp hybridization, sp2 hybridization. 1 electron moved from here to here, and it went to sp2 hybridization. So let's see this sp2 hybridization happening here. So we'll get 3 sp2 hybrid orbitals and 1 p orbital. So this is my p orbital, this is my sp2, this is my sp2, and this is my sp2. Similarly here also, correct? Now what will happen is this will form a bond. So this is my sigma bond, this is also sigma bond, sigma bond, sigma bond, sigma bond. And what about these p orbitals? They'll form a pi bond like this, right? and thus if you see it has a double bond. So first bond is a sigma bond, second bond is a pi bond. Correct. Same thing we'll do for C2H2. C2H2 also we have same electronic configuration, and now one electron moves from here to here. So in this case it went for sp hybridization. All the orbitals are, these two orbitals are used here only, sp hybridized. So if you see the hybridization, it will be something like this, right? So this is my sp and this is my sp, but other things are remaining. P and P are, this is P, this is P. Correct. Now if you see with sp it will get attached, and this sp is used for sigma bond. This is also sigma bond, this is also sigma bond. So now two p orbitals are free pair actually. So this will form one pi bond, and the other one will form another pi bond, right, like this. So it will have structure something like this, one sigma bond and two pi bond. This is also sigma bond, this is also sigma bond, right? Find total number of sigma and pi bonds in this following structure. So in C2H2, if you see, as I just explained, the first one is the sigma bond, second is the pi, sigma, 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 sigma. So it has 1, 2, 3, 4, 5 sigma plus 1 pi. We talk about this, there's first sigma and 2 pi, 4 sigma, third sigma. So 3 sigma plus 2 pi.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.